I've always found these steering wheels for video games really cool, so one day I just woke up and said, "Hey, it'd be really cool to build one of those." So I did. So at first, I was planning to build this for my PS4, as it seemed like the most obvious thing to do. Also, my brother enjoys racing games, so I knew he'd put it to good use. So I got to the drawing board and started designing a button layout, keeping in mind what each button did, making sure to include all of them. For example, the steering, which would be the x-axis of the left joystick, was the rotation axis of my steering wheel, while the pedals were the L2 and R2 buttons to accelerate and brake, and the gear shifter would contain those 4 buttons, as they're often used to change gears. The rest of the buttons were on the wheel itself. Then, I got researching to find out exactly which microcontroller and software I would use. My first thought was the Arduino Leonardo, as I knew it had input device emulation capabilities, and that seemed to be a nice idea. However, the software was a deal trickier. It turns out, PlayStations have this special communication method which has some secret protocol which, if you don't replicate exactly and you don't know the keys and whatnot, the PlayStation would not detect your device as a controller. So then I went down this rabbit hole of people saying it was impossible, people saying they'd done it, oh but turns out it was for a PS3, but then they said they have the PS4 one, but then you need a USB host shield, and suddenly you've ended up in a project to control an Arduino with a PS4 controller, and forget it, let's just emulate an Xbox controller instead. Because there's this library for boards like the Leonardo called Xinput, and it does just that, turn your board into an Xbox controller, with no USB host shield required. So I bought the Arduino Leonardo, which came in this cool plastic case, which I wasn't going to use, but whatever, some buttons with straight pins, and a bunch of potentiometers for the pedals and steering. And I started designing on Tinkercad, because does it have corner wedges? No. Does it get corrupted every time you try to import a polygon with more than 10 vertices? Yes. Will I bother trying to find a cat that makes my life easier? No. Wait. I used this cool steering wheel model I found on Thingiverse, and based on it, I made the main body for the buttons. So the button pieces come out of there, and then I have the board with the buttons in their respective places, with a neat hole for the cables, and then you put the board into there, and the buttons can be pushed in and they don't come out, and they don't go in. Perfect. I also made this part for the joystick and this kind of core part for the Leonardo, and any common ground side need, and then had to think about how I'd actually turn the wheel. I used this bearing from Thingiverse and made it so that I could glue the exterior part into the steering wheel, and the interior, which would be connected to the rotating part of the potentiometer, could stay static with the external axle I'd think about later. So with the pinout planned, there was no issue in printing the wheel first and then worrying about the pedals and gear shifter. So I left the printer to do its thing and started thinking about the pedals. There really were many options for exactly which system I could use, as many as there are to turn linear motion into rotational motion for my potentiometer. There were a few designs online, but I decided to go with my own. So when you step on the pedal, it turns about this axle, so you can place the potentiometer here, glue the rotating part to the rotating part of the pedal, and bam, you've got yourself an electronic pedal. Cool, so now I had to build a newly printed steering wheel. I started by placing all the buttons and joystick on the button board, and they fit perfectly, so I assembled that with the main body and then got my Arduino Leonardo, started connecting all the pins together, and made a common ground by soldering cables onto a copper wire. Then, a friend of me told me, "No bro, for buttons you do digital read, so it's a common VCC," and I said, "Oh, that makes sense." Turns out my intuition had been right from the beginning. Undoing silicon is pain. I then read through the documentation for Xinput and made the full code for my controller. I tested the buttons to make sure they worked correctly, installed the potentiometer and bearing, tested those, and once everything was working fine, I enclosed this maelstrom of cables, attached it to the frame, and finished this absolute beauty. Then I printed both pedals, one of them broke, but I fixed it, I connected them to their wires. Oh wait, which one was it again? And they worked! Now all I needed was the stationary axle for steering and the gear shifter. For the former, and after realizing that the controller wasn't compatible with PlayStation and that I'd have to use it with my laptop, which no problem for me, Sax being my brother, I decided to make a clamping system for tables to hold the axle. An adaptable one! So I turned these clamps into my own super cool design on Tinkercad, made the axle and put it to print. Oh, also, given that I couldn't use it for the PlayStation, don't ask what these special PS4 buttons do. They're just fidgets. Now, the gear shifter. How do I make a stick that can push different buttons when you move it in different directions? I came up with this design which used the built-in Tinkercad ball joint for free movement, restricted by this cross-shaped hole, and then I had the buttons placed at those ends, so that when I moved the stick to any one of them, it pushed the button. I then added this cool engraving, and I don't care it's not a PS4 controller, my laptop's not an Xbox either, okay? And... oh wait, how do I keep it from rotating? Rubber bands, of course! I then wired it all up and connected it to my laptop for the final test. So now I have a steering wheel, pedals and gear shifter with all the buttons I'd need to control any racing game. I can attach it to any table and any PC, and I could even pair them with some VR glasses. Someday. Overall, it was such a cool and fun project. It was my first time building a custom input device, but there are so many possibilities, and I might use this system to build some crazier controllers in the future, like, I don't know, a clicker that gives you more clicks per second the more radiation you're getting. Anyway, thanks for watching, please like and subscribe, and I'll see you next time.